Good morning all, it's project time again and we're going to be doing something a bit different, which I think I say every time, but this one is different to me because I don't have masses of experience in it, so you're pretty much learning with me rather than from me. So get yourself, first of all, before we can start, you need to make sure you can actually build Away3D. If you're working in Flash CS5 or 5.5, you're going to have to ensure that you can target Flash Player 11 because by default that's not the case. So you need to do a quick search for target Flash Player 11 in CS5 and you'll be linked to this Adobe blog which will give you an MXP file to just install that will update your Flash to give you the following options. So once you're into Flash, after you've done the MXP install, if you go File, Publish Settings, you'll be able to target Flash Player 11 and change the hardware acceleration there to direct. If you're not working in Flash Professional, that's fine. You can do this tutorial in Flash Develop or whatever you want to, as long as you can target Flash Player 11, you're sorted. So, waffle aside, get yourself to away3d.com/download, and for the sake of this tutorial, we're going to be using these source files. If you're going to be doing quite a lot of Away3D, you might want to just get the SWC, put that into your libs folder in your install, your Flash install, and that way you don't need the source files every time. They'll just be core to your Flash, like movie clips and sprites and so on. But I'm going to download that. I've saved it to my desktop, so let's just jump there now. When you've downloaded that source folder, you will be presented with the following. That's what we get. Really, we only want the contents of this source folder. So what I'll do is I'll drag that out to my desktop and I'm going to rename it rename it for the sake of this project. So SRC will become Project 7 and that's where we'll be working from. So we've got the Away3D folder there, the Away3D package, and our source files will go here so that they have access to them. So back into Flash or your preferred environment, just going to quickly set up my SWF. I won't be using the timeline or the stage at all, it'll all be code. So let's put the FPS up. The whole point of Stage 3D is that it's meant to be fast, so let's put it to the test. We'll put the size up, we'll go 800 by 600, and we'll make the stage solid black. Just make sure that, again, your published settings are set to Flash Player 11 and that the hardware acceleration is set to direct. So you have to be direct mode and hit OK. What I'm going to do is save that, not quite sure where that is, save that into my newly made Project 7 folder and let's call it main. So that's my main file, hit save, and we're pretty much good to go. Start off, we're going to make the document class, so since I'm in CS5 here, I'll just type main as the name for my document class and hit the pencil to have it generate most of it for me. Save it straight away, save it next to the FLA file, as we always do. Again, if you're working in something other than professional, get set up in your usual way. And we're going to start dead basic. Within the next 5 minutes or so, we should have a rotating cube on screen, 3D cube. No 2.5D this time. Right, so we've got the basics. We're going to have to import a few more things, but hopefully it'll do that for us as we type them out. I'm going to start by making a 3D view. So a variable for my class, I'm going to make it private, why not? Private var, we'll call it view. So this is how we're going to view the 3D world. Make sure that our code hints are on by saving the file. Yep. So in here we want to type view, and if we've saved in the right place we should get access to this view 3D, which we do. So we're making a view and it's going to be a view 3D. We'll just get that up and running before we worry about anything else, but we will add a cube to the stage in a bit. In the constructor, let's set up the view and start rendering. So, view equals new Away3D. We don't need to put any additional information in there for now. What else do we need to set? We can set the camera position. So if we do view.camera.position equals, and we want to make a new vector 3D because we're working in 3D now, so we need the X, Y, and Z dimensions. So do new vector 3D. That will get imported for us. And in there, just put, let's say, 0 in the X, 0 in the Y, and minus 200. So we're moving sort of towards us out of the screen with the camera. And we're going to turn it to look back at the origin. So if we do view.camera.lookAt, and in there do a new vector 3D, which we won't pass any information to, so it'll just be 0, 0, 0. So the camera will be positioned 200 units back towards us, and it'll be looking at the origin of the world. So it'll be looking at where we spawn our cube when we eventually get to that. Let's just comment that so we know what's going on. Position and target the camera. Okay, and add the view to the stage. Add the view to the stage. Just as you would any old display object. Add child, view. Let's start rendering. So we're going to render every frame, which means add event listener, event.enter frame, and let's call it render loop. Just call it render, I suppose. Outside of the constructor, just quickly make a function. Let's make it private function render, and it's working with an event which will now get imported for us. So far we've got 4 things imported. Make sure yours match if they weren't brought in for you. Dead simple this bit, we just want to render the view, so we do view.render. Bit of a pointless comment, but hopefully at this point if we save it, go back to our flash file, because the problem is with CS5 at least, if you're in CS6 it's not an issue, it should just work. CS5 was built to target Flash Player 10, so if I just test my file at this point, it'll probably break. Takes a lot longer to export as well, doing this. Yeah, so it doesn't work because it's not targeting Flash Player 11, so it's missing a lot of the information it needs. What we need to do, because we set our publish settings to actually target Flash Player 11, we can do a publish preview to have a look. So if we go that route, we should be able to at least get something running. Won't look any different. There we go. There is something there. We can right click and see that it is Flash and it's running Away3D. Let's maybe change the view colour so we can see something's going on. So our stage colour is black. If we change the background of our view, so let's do view.background colour. Set that to something hideous like red. Save that, back to the main and publish preview. You can just hit, I think it's Control F12 if you're on Windows. My function keys are set to control my volume and stuff, so it won't work for me. But there we go, we've got a red view, so it's definitely working. We don't need these windows anymore, let's get rid of them. So let's add a cube. Okay. What we'll eventually do is split these into their own functions, but just for now, for the sake of this first part of the video, we'll keep it in the constructor. So let's set up the cube, or a cube, which means we're going to need a variable for it. So let's go back up here and do private var cube. This is going to be a mesh, and this will be imported again because it's part of Away3D. So if you type that line, it should import it for us, and it has. Back down into our constructor, set up a cube, so we'll do cube equals new mesh, and then in brackets we tell it what sort of geometry to use, and we want to use cube geometry, so we type new cube geometry, hit enter, and it'll get imported again. Just make sure it has. And I just want a default cube, so I'm not going to pass any additional information in there just yet. And that's made a cube for us. Let's add that to the scene and see if it works. So we'll do view.scene.addChildCube. That should be it. So let's save that, go back to our main file and do a publish preview. Derp. There we go. We have what I promise you is a cube. It looks like a very flat 2D thing at the moment, so let's just tweak it. We'll make it rotate over time. So before we render, let's rotate the cube. Rotate the cube. Cube dot, and then we've got 3 different ways we can rotate it. We can do rotation X, which would sort of roll it backwards, rotation Y, which is the one I'm going to go for, and rotation Z, which would sort of roll it. It's like a barrel roll. So if you want to do a barrel roll, do rotation Z. I'm going to go for rotation Y, so it spins in place, plus equals 2 degrees every frame. Publish preview again. Tap your foot while it publishes. Maybe have a drink actually. And there we go. We have a rotating cube. Not too bad for 10 minutes work if you've never done this sort of stuff before. So for part 1 we'll leave it there. We have something on screen so we know it's working at least. Make sure that that all made sense. Go back and comment it if you feel it needs more commenting. Yeah, I'll see you in a second. Okay, the next step in the evolution of our cube is to put a material onto it. And we'll start really simple. We'll just have maybe a solid colour before we look at putting a real texture on there. So we'll just get to the bit in our code where we handle the cube and possibly break it out. So we could refactor this a bit. We'll do that first. So everything at the top here of my constructor that has to do with the view, I'm just going to cut, or maybe leave the comment. So I'm going to cut that code and just set up the view. And I'll make a function for it. So we'll call this init view, for initialize view. So that's a function. And we need to make the function, so let's make it private as well. Private function init view, and just paste in the code that we'd cut out. So we can now handle anything to do with setting up the view in there. And I'm just going to change the background colour back to black. So we're going to make this a bit more readable in our constructor. The rendering bit we'll leave for now. I'm going to cut this cube part out of that, so let's cut that. And I'll actually set it up here. So init cube. Just move the comment up as well. Need to make a function for that. Let's just get rid of some of this white space. Collapse this. Just trying to make it more readable. It'll make life easier later on. Init cube. And same process, paste in the code. We will be using that one, so I won't collapse it for now. And this last bit, we're not actually rendering anymore. We will be doing the rendering, but we're going to be updating. So we'll call start the update loop. Start the update loop, and instead of being called render, let's rename it update. And rename the function to match that. Because it's not just rendering it. At the moment it's rotating the cube, and we'll probably do a bit more in there later on. But let's get a material going. So we'll save the material as a property instead of just making it on the fly. So up here where we've got the view and the cube, I'm going to make another variable, private var, and we'll call this material for now, just a generic material that we can come back to and edit a little bit. And to begin with, we'll use a colour, American spelling, colour texture. Now colour material. Oops. Schoolboy error. Let's try that again. Right, colon, and start typing colour material. There we go. And that will import from Away3D.materials. And a colour material does exactly what you imagine it does, it's just a solid colour. And we'll set that up before we do the cube. And we need to do the material first because we need to have it ready before we make the cube. So we'll do init material. So material, make another function. So do private function init material. And in here we'll use this material variable we've got. So we'll do material equals new, and then code hints pop up for us, and we want the top one because that's the type we've told it to be. Told it to be a colour material, so it expects we'll make a new colour material. And in there we just pass a colour. So we could even do a random colour, but just to check it works, we'll make a blue one. So we'll go with RGB, so it's 00, 00, 0, and then full blue. So that's made a material. We need to actually apply it to the cube though, otherwise it won't have any effect on our scene whatsoever, other than taking up a bit of memory. So in the init cube, after we've made the cube, let's just do a new line, and we'll do cube.material equals material. Save that, do publish preview, take a sip of your drink while it builds, because it does take a lot longer. And there we go, we've got a blue cube, spinning nicely in a black environment. Yeah. Bit boring though, isn't it? So if you want to use solid coloured cubes, that's how you do it. There's really not much more to that. I could show you how to do different sort of lighting and shadowing on just that, but I'm going to show you that later anyway, and that will affect a colour material in exactly the same way as it affects the next sort of material we're going to do, the texture material. So we'll go about editing that then. I'm going to go back to the top where we made the material and just delete the type from it and redo the colon, so we're prompted again. And this time I want the texture material. And that's imported for us. We could have just updated the colour material import, but I'm going to leave that in case we want to make something like a floor that's a solid colour. So this time it'll be a texture material, and we need to go and change the way it's initialized because it's no longer just a colour. So if we get rid of everything up to the word new, including the word new, type it again and do a space, it'll prompt us for a texture material this time. This time when you open brackets, it needs a texture 2D base, which we'll have to make, and we're gonna actually need a texture as well. So I've got a few that you can use that are saved in with the source files, so I'll make them available. But what it eventually entails is doing a new bitmap texture. That's the one. And this is where you pass in the bitmap data that you've got your texture on. So we're going to make that now, or rather import it. So I'm just going to go to my FLA. If you're not working in Flash Professional, you'll have to go about importing your image to your environment in whichever way you see fit. But I've got this crate texture, just went to Google and put free crate texture. I'm going to drag that in so it's imported to my library. I could have gone file import to library, but it seemed a bit quicker. Drag it on and delete it so it stays in the library but it's not on stage. Then I'm going to right click, go to the properties and edit this a bit so that we can actually make it with code. I need to go to my ActionScript section, tick export for ActionScript and just update the class name. Don't want it to be called crate.jpg, I want it to be crate. And that will do. Press OK, and we can now use that. We can make an instance of that bitmap data. Back to the main AS file, into our init material. What we'll do before we actually make the material, we'll quickly make a version, an instance of that crate bitmap. So let's do var material bitmap equals new crate. That will store an instance of crate into material bitmap, and we can pass that into this bitmap texture. Make sure you close two sets of brackets there and save the class. This time when we test, we should have a crate, right? A perfect crate with every side looking the same. The tension's killing me. But we don't. It's gone wrong. Or has it? It's not actually wrong. What it's doing there, it's is actually a benefit to us in the long run. It's got the UV coordinates of this cube geometry set up to be well, what it labels as a tile 6 format, which is what you might have seen here in the images when I was dragging in the crate. So if I just quickly open this in Photoshop, what your cubes are actually doing in Away3D is using a texture in this way. So the bottom of the cube is taking the top left of the texture, and so on, as you can see, with every section labelled. And you've got to make sure that your textures are a power of 2 in each dimension. So if the crate texture we had there was 512 by 512, and so is this overlay that you can have. If you had it 500 by 500, the texture wouldn't work. You've got to make sure it goes powers of 2. And then from there, if you paint into these sections what you want to see on each face, then you'll get a nicely wrapped cube. And I've got a few textures here that we'll come back to and use later, but if I just open that one as well, you can see that I've butchered the picture of a house here or block of flats to make a texture that should wrap properly to the cube when we come back to it, and we'll give that a go later on. But what I actually want to do is change this mesh so that it uses the cube texture in the way we first thought it might. And I need to edit the cube mesh for that. So we're going to come here into the init cube function. I'm just going to change the way we make the mesh. So instead of directly putting a new cube geometry in, I'm going to click that, and we'll just call that cube geo. So we're going to make a variable called cube geo. We'll make it just above our cube geo, and it's going to be cube geometry equals, and we'll just paste it back. And then before we actually make this mesh, we're going to change one of the properties of this cube geo to make it use the texture in the way we were first expecting, where it just gets plastered on every face the same. Do cube geo dot, and we want to change the tile 6 flag. Tile 6 means that the texture's tiled onto the 6 faces, and we just put false for that. So it'll just put the same full texture on every face instead of tiling. Save that one, give it a go again, and we should have a cube, a crate. Have a drink. Woohoo! There you go, a crate. Yeah, should we turn it into a house instead while we're at it? Maybe add a floor as well. So we've got a few things to do before we move on to part 3. Part 3 will have lots of different things in the environment and try and make some sort of scene. But what I'll do is quickly add a floor. So I'm going to come to my constructor, set up the cube, and just below that we'll set up a floor. Now I'm probably not going to access the floor much later on, so I won't bother for now cluttering this part up. But if you want to have a reference to your floor, make sure you do a variable for it. It's going to be another mesh, but we'll go through that in a second. So let's do init floor. Probably won't use this again, so I'll put it somewhere near the bottom, just underneath my update function, and let's make private function init floor. And this is going to be another mesh, so we'll do bar floor equals new mesh, open brackets, and this time instead of being a cube we'll just go with a flat plane. So we'll do new plane geometry, and that gets imported for us. You can see all my code got knocked down. We could go with the default of 100 by 100, but that would be smaller than our cube, so it would be a bit pointless. So I'm going to make that bigger, let's say maybe 2000 by 2000. Close both sets of brackets, and let's add that to the world. So we'll do view.scene.addChild floor. We'll need to reposition it as well, because the registration point of our cube is in the middle of the cube, so the cube actually goes 50 units below 0. So we need to position this floor at -50. So we do floor.y equals -50 to move it down in the y-axis. And it needs a material as well, doesn't it? So let's just put a comment in here. Make a new plane. Add a colour material to it. So we could just do floor dot material equals new colour material, and then put in a colour there. Maybe just go with a dark grey, something like that, and then add it. Let's check that that works. Get very bored waiting for these to publish. There we go. Got a cube spinning around on a floor. It still looks very flat because there's no lighting, there's no shadows. We will sort that, I promise. One step at a time though. So this floor I probably won't change again. There's a small chance I'll have to come back and change the material actually, but for now we can collapse it. Let's go back to our cube and look at using a different texture. So we can look at one of the fancy textures we had instead of just this plain crate. So I'm actually going to comment out the tile 6 part. So it goes back to using the 6 tile wrapping method. And I'm going to import a different texture. So I'll go back to my FLA and let's go with that building texture that we looked at. Drag that in, delete it. Same process again, we need to be able to make this with code. So let's go to the properties, ActionScript, export for ActionScript, and we'll just call it building texture. It's okay. And now instead of, where are we? Instead of initializing a new crate texture, we're going to use building texture. That's really all we have to change. We've commented out the tile 6 flag, so it should work straight from the off. With one little problem, which you can probably foresee. Yeah, it's very squat, isn't it? There aren't many blocks of flats, at least near me, that are perfect cubes like that, so we need to change the size of this a little bit. So I'm going to go to where I initialize the cube, and I'm going to change the size of the geometry. We can do that in the constructor, when we make it here in the call, when we make a new cube. Stop waffling and do it. Let's just put in some sizes. So maybe go 50, 100 and 50. So it's half as wide, half as deep as it was by default, but it's still as tall. And it should look more like a building, except buildings don't spin. At least not where I live. There we go, building, and it's different on each side. Well, it's got two different possibilities. Two of the sides are the same, and the other two are the same. The top and the bottom have got a different texture which we can't really see, so let's just rotate it in a different axis. If we go to the update, we'll rotate it in the Y and we'll rotate it in the X as well. Cube dot rotation X plus equals, we'll just go 1 with that one. So it'll rotate at half the speed around the X-axis. And hopefully we can see these grey stony textures on the top and bottom. And there we go. So you can see that the texture's mapped or wrapped properly onto the object. We're intersecting the floor a little bit now when we rotate, so we've got to be careful of that. There's no danger of this ever being an issue. We're not going to have rotating buildings in any scene, so I don't think we need to worry about that too much. But it works. Okay, so let's do a bit of illumination then. We'll quickly get the lights working and I'll leave shadows for the final section where we make something a bit more worthwhile. So we'll just do a light now. And we need to actually set up the light before the materials because the materials need to know which lights illuminate them. So underneath the init view, we're going to set up a light. say init light. And up at the top here in our variable section, let's add a new one, private var light. This will be, we'll start with a point light. So a point light is basically a point in space that emits light. That should get imported for us there, away3d.light.pointLight. We need to make this init light function. So let's just do that underneath the constructor. Private function init light. We don't need a var, we just do light equals new, and we get prompted again, point light. Now what you might imagine there is that you just add it to the scene and you're done, but that's what I tried, and I was tearing my hair out for quite a while wondering why it didn't work, and I finally found that you've got to tell the materials to use the lights, which does make some sense, but it's a bit fiddly. So with the light made, let's just add it to the scene. Do view.scene.addChild light. Maybe reposition it as well. So let's position it light. Okay, can we just move the Y? Yeah. So let's set the Y to 200. Maybe do light.x as 100. So I've just moved it to the right and up a bit. Maybe put that 400. So it's way over to the right, and it's 200 units in the air. That won't work. You can try that. I don't really want to waste the time building it again, but that won't have any effect on our cube until we tell the material to use this light. So where we initialize our material, we also need to tell the material to be affected by the light. So tell the material to consider light. Whoops, I should do that after I've made the material. Comment there, and we'll do material dot light picker. This was another thing that took me ages to find. Equals new, and we want a static light picker, and that will get imported for us. There we go. And then in brackets we need an array of lights. Now we've only got one light, so if we just quickly make an array by using square brackets there to put our light into it. This is if you want more lights to affect your material, which makes sense in a lot of the settings you'd use lights. We've just got the one, so we'll make the static light picker, tell it an array of lights to use, and then assign the materials light picker as that static light picker. Save everything, and now go and have a look. There we go. You can definitely tell light's affecting it, but it's a bit unnatural. For one thing, buildings don't shine like that, and lights tend to affect more than the faces directly looking at them. So let's just play around with our light a bit. What we could do is move it a bit towards us. That'll help. So let's also change the Z position of the light. Or we could just do the whole thing by doing light.position equals new vector 3D, and we can go 400, 300 in the Y, and let's move it towards us like the camera, so we'll do minus 200 again. We can also change the colour of the light, light.color, and I imagine by default it was bright white, so let's maybe make it a bit darker, a bit duller, or give it a tint. Maybe go full red and not so full in the other two. So, I don't know, CC. And finally we can give it an ambient value. So we can do light.ambient, and this is, it's a fraction of the light that affects all faces. So as you might remember from the scene we just saw, the back of the building was totally pitch black because it was getting no light at all. This ambient setting tells a light's value to be applied to all faces a certain amount. So if we go maybe 25%, 25% of this light's brightness will be applied to all faces. Save that. publish it again. Let's have a look. That's not too bad. It's very red. I probably should have gone with something like blue for a daylight colour. It's still shiny though, so one last setting. Let's take the specular off. Do you do that on the material? See, this is new to me, so I will make mistakes. Let's just check, see which one has the specular setting. Material dot specular, there we go. And let's just drop that to 0. No specular, we don't want it to shine. Change this colour a little bit. Maybe put the red down and the blue up. And if that's working, we'll leave this section at that. So we know how to do materials. We can do the tile 6 or not. So you could have a crate or a building as you've just seen. We know how to add a light. And we know how to make the materials use said light. We can take the specular off. We can also apply ambient light to all faces. So we're definitely getting somewhere, especially as we've never done any Away3D before. Okay, section 3 will make something a bit more worthwhile, something we can move around in and see lots of different objects, have them casting shadows on each other as well. So far so good, thanks for sticking with me. So to finish up then, we're going to build a little scene, going to make a little city actually. I've got loads of ideas of where this could go, but obviously it's new to me. It's only an hour-long video, so I've got to rein these in. So really we'll go for a block of buildings or buildings in blocks. We'll get the shadows working as well, we'll have a look at that. And try to get the camera to move about a bit. That's very new to me as well. That's the goal, let's see how it goes. So we're going to start by pretty much getting rid of any reference of our reference to our cube here, because we're not going to use that anymore, we're going to make buildings. So we'll make a building class. But start with, we'll get rid of cube, get rid of it there, get rid of the init cube function, get rid of that, we don't need you anymore. And then in the update, we don't want to access cube anymore, let's get rid. Okay, so let's start making a city. Back to the constructor, we've got the view being set up, that's okay, then we do the light, okay, then we do the material, which isn't actually being used at the moment, but we could change that to be init materials or init a different material later. And then we want to build the city, so we'll make a function to build a city. Let's just call it build city. We could maybe pass in a value to have a city of different sizes, but for the sake of getting something working, we'll just hard code things and you can take that on yourself to make it a bit more reusable. So let's make a private function build city, and in here I'm going to have 2 for loops, one within the other, that will go across to make a grid of buildings basically on our floor. To start with though, we'll have a city size variable, so let's say var city size equals, now from memory I think our floor is 2000, and we don't want the floor to be compensating its position now, so I'm going to change that. I'm going to get rid of that. The floor will just be at 0, 0, it will be on the 0 position in the y-axis, and we'll make the buildings compensate for that. It does mean that we're going to have to move our camera up, because that's going to be too low, but we'll come back to that. I'm getting ahead of myself. So city size based on the floor, let's say 1800. So it's not quite as big as the floor. And then we'll do loop across in the x direction and again in the z direction. So 2 for loops, for open brackets, let's have var city x equals, and because the middle of our world is in the halfway point of our floor, we actually need to start at minus half of this. So we'll go minus city size over 2. So that will be at minus 900 to begin with. Could have just hard-coded that, but makes it easier to change that later. Then we want to go across until we've gone half the other way. So we'll do city x is less than city size over 2. So all the way from minus 900 until city x is bigger than 900. And then how much do we want to boost it by? Where do we want our buildings positioned? So we could just hard code a number again. We could do city x plus equals 200 or something like that. But I think what I'll do is have 2 more variables. We'll have a building size and a road size. So we'll go var building size equals, what were they? They were 50, weren't they? Maybe a bit bigger than that. Say 100. And var road size, rod. It's a very different measurement. Road size, we'll say 50. So 50 units for the road. So when we've looped across in this x direction, every time we jump, we want to go by building size plus road size. So effectively we're jumping 150 units every time. You can play around with that. For the z direction, I'm going to copy the whole thing, paste it and change the x's to z's. And we've got our for loops ready. So in here we want to make a building and position it based on city x and z. Right then, so that means we're going to have to actually make a building. So just do the setup for it. We'll do var building of type building, which we haven't made yet, equals new building. We could pass in a material there to the building class as we make it, so we might come back and do that. I think to begin with we'll just quickly make a colour material inside the actual building. But without further ado, let's make that building class. I'm going to save my document class, go File, New, and make a new ActionScript 3 class called Building. Hit OK, and first thing to do is save it in the same location as everything else so that we get the code hints. And my building is going to extend an Away3D mesh, so I'm going to have to import that. Import Away3D.entities.mesh, and then tell our building class to extend mesh. And there we go. It's set up now to act in the same way as an Away3D mesh. We're just going to give it some extra information when it's constructed here. So let's get rid of this comment, or rather have a different comment. We're going to use the super class constructor. So we're actually going to make use of meshes constructor from within our building. To do that we just type super, open brackets, and you can see we've been prompted for what goes into meshes constructor. We just need the geometry again, so we'll go new cube geometry. And for now, we'll just hard code the numbers we had for our building, but we'll come back and give it some randomness later on, or maybe even pass in a size. Cube geometry will go 50, 100, 50 again. So we know that size makes sense with our building texture because we've already done it. We'll make a material quickly. Make, add a material. I'm just going to go for a random colour here, so we'll do material equals new, not material, colour material, and make a random colour in there by doing math.random times white. Anything else while we're here? Yes. We need to offset the Y position based on the height, because the pivot point of this cube is in the middle of its volume, of its mass. So we need to move it up by half of its height. Its height's 100, so we need to move it up by 50. So let's do y equals 50. that should be enough to work with. There's a lot left to do there to make it look like a building, but it will serve its purpose for now. So let's go back to our main class and carry on with this build city function. So we've already got it to make enough buildings to populate the grid, we just haven't positioned them or added them to the scene. So position it, building.x equals cityx, building.z equals cityz, and then offset. No, we've done that. We did that inside the building. Offset the y. We just need to add it to the world. So we'll do view.scene.addChild building. That should work. I don't think our camera is in a very sensible position anymore, but let's see. We can always move it. Yeah, I think that's the makings of a building there in front of us, and the floor's just black here. Yes, let's move the camera back into the main class, and where we init view, instead of positioning the camera at 0, 0, minus 200, let's go 0, 200, and minus 500. So there'll be buildings below us, buildings behind us, to the side of us, but we'll be above them hopefully, and we can see them. Especially as we're looking back at the origin of the world. Woohoo! We have a very primitive town. I think there's a bit too much space between them, so either the roads need to be smaller or the buildings need to be bigger. Or both. Let's just keep going with it, keep adding to it. Playing around really, this isn't an exact science, it's not something I've made before. All new to me, as I've said plenty of times. Okay, let's start by texturing our buildings. We've already got this material, we might as well use it. We can always come back to this later on and have init materials, make it plural, and pass in a random texture every time we make a building. I think I might do that, and I've actually got a little plan for it. I've made a little windows texture that's actually transparent for everything except the windows, so we could have the random colour that we've already got and plaster these windows over the top. So we'll do that later, but let's when we make our building we'll pass in our material. So we'll just pass material in there, go back to our building class and have it expect a material. So it's going to take, can't use material because it's already got that there, or we shouldn't use it. We'll just call it mat, and this will be a texture material. Make sure it imports, and instead of doing material equals new color material, I might just comment that out so we could always come back to it if we need it. Here we'll just do material equals mat. Save that, and just before I test it again I want a bit of random size. Instead of just going 50, 100, 50, let's have a bit of variance. Maybe go for bar, let's have a scalar equals, and let's say between 1 and 2, so they could go from their normal size as they are now or be twice as big. So let's do 1 plus math.random. And then for each of these we'll do 50 times scalar, 100 times scalar, and then 50 times scalar there. Also means that we need to do the same with our Y position to make sure that the building is repositioned based on its height. That should give us a nice bit of randomness. We should put some random rotation as well so they're not all facing the same direction. Main class needs to be saved and we can test it. Okay, that's a bit more like it. Now might be a good chance to do some shadows to get the floor receiving shadows, maybe make the light affect the floor as well, because at the moment it doesn't. So let's take a break from our building to do the shadows then. Back in the main class, let's find where we make our material first of all. No, not our material, it's our light. Our light. Find our light, there it is. Point lights in Away3D don't cast shadows, they're not allowed to cast shadows just because of the way they work, I suppose. We need to change this, so instead of being a point light, we're going to get rid of that. Do new and start typing directional light, and we get prompted for it. Just hit enter to accept that and it will be imported for us. And let's just check, yep, lights.directional light. You're going to have to update the variable, so light needs to reflect that. Directional light, back to where we initialize it. Now that it's directional, it needs somewhere to point. So I imagine by default it just points straight forward. We want it to point back at our origin. So when we've positioned it here, light.position, we'll do light.lookat, just as we did with the camera. And we'll just do a new vector3D, exactly as we did with the camera. And now that we have a light that can cast shadows, we need to tell it to cast shadows. So we'll do light.casts shadows equals true. You can try that and it won't work. Things are never that easy. So again, as we did with the illumination in general, we have to tell materials to accept shadows as well, which was a bit of a pain. What's happened there? Oh, sort of hovering between a building, I imagine. That's why you can see under the roof. So what we need to do is tell our material to accept shadows, but more importantly, it's the floor this time. The floor is the one that's really going to show these shadows off. But where we initialize the material, when we've done the light picker, we also need to tell it to take shadows. So let's tell the material to receive shadows. We do that by typing material.shadow method equals new, and then there's a choice of shadow methods, and I think the best one I came across when fiddling around was a filtered shadow map method. That's the one. Hit enter there, open brackets, and you need to tell it which light is casting the shadows. And notice this time it only takes one light and it has to be directional, which leads me to believe, I've not tried this, that you can only cast shadows from one light. I don't know if there's much truth in that, but it only takes one light, and we'll pass it in there, we'll pass light. So our building material should now receive shadows. Let's just try it. Our floor, however, won't. We'll fix that next. You can just about see there on the left and at the bottom that we have shadows being cast on our buildings by other buildings. Just refresh it, see if we get a building that's not blocking the view. There we go. You can see that that building is casting a shadow onto that one. So that's working, but notice the floor is totally unaffected. And that's because we haven't told the floor's material to receive light or to cast shadows. So we need to do this. We need to copy these two lines and put them on our floor's material. So when we make the floor, we need to tell it. Let's see if we can do it just by putting floor.material in front there. If this doesn't work, we'll have to come back and make the material separate instead of just doing floor.material equals new color material. Let's try that. That worked. Notice there that our floor is now receiving shadows. If I just refresh it till we get a better view, not that one. There you go, you can see shadows clearly on the floor. And there you go again. So that's working quite nicely. I think the shadows are quite low in detail. There must be ways of boosting that, but being a complete noob, I don't know. It looks okay to me. Right, let's rotate our buildings randomly. Go to our building class. Not totally randomly, they're going to be in sets of 90, but let's rotate. I can't even think how to word the comment. Rotate by 90, 180 or 270. So we can do rotation y equals, and then we'll make an integer of math.random times 4. So that will actually be between 0 and 3. And then times that by 90. So it should give us random rotation. We've not got the best texture on our buildings to actually evidence that, but it will be a bit more obvious when we change that, which we can do now. There's no point me sitting there building it again for the sake of testing a very minor change. So let's have a look at having more than one material, should we? So instead of having init material, I'm going to have init materials, change my constructor to match it, and I'm going to use the window texture that I showed you. So this should work. It works in my head. Init materials, and we're going to have a list, an array to hold these. So instead of having one material, I'll keep that just to save any errors, but I'll also have private var materials, and this can be an array. So this will be an array of materials, and then when we initialize them, here, let's make the array. So materials equals new array. And then I'm going to have a for loop that makes a certain amount of materials, random colours with the windows applied. So we've already got the logic for making a random colour. We've done it before in previous tutorials, so that's nothing new. Let's just set up the for loop. Loop so many times to make textures, materials. For, open brackets, say var I equals 0. And say we want maybe 5 for now, we can change this. I is less than 5, I plus plus. We're going to make 5 different coloured textures with our material, our Windows material on. I'm going to use most of this logic, I think, so that can go there. Let's just indent them. And now this material bitmap, instead of directly taking it from a texture that's in our FLA library here, I'm actually going to make a new bitmap data. New bitmap data. Need to actually import bitmap data, so let's do that there. That's done that for us. New bitmap data, 512 by 512. Transparent, no, we don't need it to be transparent. And then we can give it a random colour here. So do the logic we've already done, math.random times white. And we have our new bitmap data that we're then going to stick our windows over the top of. But just to make sure it works first, we'll set it up as just a colour on its own. So the material then, we don't want to use this material here because we've got the variable up there. Although we could do, we could just delete it from there. Get rid of that. And here, do var material equals new texture material based on that bitmap data we've just done. It's been told to be affected by the light. It's been told to to receive shadows. So that's set up. All we need to do is make sure that our buildings now, when we make them, take one of our materials instead of using that standard material. So we'll do int Oops, sorry, we need to actually access the array. So we'll do materials, square brackets, int, and then in brackets there, math.random times materials.length. The int will round it down for us so that we definitely get an index that's in bounds. So materials, square bracket, int, math.random times materials.length. Make sure all your brackets add up, your square brackets are closed. Save that and hope it works. That was a bit long-winded without a test, so quite a lot could have gone wrong there. And by the looks of it, it did. So I've done something wrong, unless it's just a very big building in my way. Don't think it is. Problem with working publish previews, it doesn't show your errors, so I'm a bit stuck when I do something like that. I'm not pushing the materials in to the list. There we go. So when I've made the material, I'm not actually adding it to the materials list. Do materials.push material. Export image, going mental. So let's test it now. Hope that that was the only mistake, because it's very hard to find them when they're not reported. Woohoo! That works. So, didn't go perfectly, but we got there in the end. Next step is to add the windows and the other bits to these so we can tell if they're rotated or not. So I'm going to import that Windows PNG from before. It's a transparent one, so it will just go nicely over the colour that already exists. It's been drawn out based on a tutorial actually by a guy called, I think it's Chris Hildenbrand, Sprite Attack on Twitter. Quite useful tutorials for people who can't draw like me. So I've got that imported. Delete it from the stage, but let's export it for ActionScript here. Get rid of the .png, so it's just called Windows. Maybe Windows texture is a bit safer. OK. And just save that, and then go back to where we make our materials here. And as soon as we've made this bitmap data, we want to draw over the top of it. So I'm going to go material bitmap dot draw, and then in brackets do new Windows texture. Save that and try it. So we should be able to tell, if that works, we should be able to tell which direction the buildings are facing based on that door there that the Windows texture has. And it worked. So you can see these two buildings here have got doors facing forwards. Can we see any others? Let's just refresh it. There we go, that one there is facing to the left. This one here is facing right, so we've got a bit of a city going on. It's working surprisingly well. So yeah, I'm going to leave that material and shadow stuff there, and let's just quickly get the camera mobile because this video is getting very long. But I do want to be able to move the camera, if only in a very basic manner. Let's go to our update function. And instead of just rendering, let's have some camera controls. Let's control the camera somehow. What could we do? We could have it so it constantly moves and you can aim with the mouse, possibly. That's probably a quick way to do it. So let's quickly say, if the mouse is to the right of the screen, we'll rotate to the right. If it's near the left, we'll rotate left. So let's quickly go if mouse X is less than, and I've hard-coded, not hard-coded, but I'm going to hard-code based on the size of our stage, which is 800 by 600. So let's say if mouse X is less than 300, or mouse X is greater than 500. Rotation, oh, not rotation, we want to do view.camera.rotation y plus equals, let's see, we need to figure out a number based on where the mouse currently is compared to these other bits. So we'll take the middle of the screen. Middle of the screen will be 400, won't it? So 400 minus mouse x. And we're going to have to divide that by quite a lot, because that'll be some very big numbers. So let's divide that by 500. So the camera, the rotation y of the camera is going to change based on the x of the mouse in relation to the middle of the screen. At least that's the theory. It's going the wrong way, but it works. So mouse to the right, we rotate left. Mouse to the left, we rotate right. So let's just fix that, and maybe do up and down as well. So instead of plus equals, let's do minus equals. Copy the whole thing, paste it underneath, change x to y. Change these numbers a bit because the screen's not as big as it is, not as tall as it is wide. So that could go to 200 at 400. That needs to be mouse y, and that needs to be rotation x to bank us up and down. These numbers need changing. That needs to be 300, that needs to be mouse y. It works. I do quite like 3D, I just wish I was better at it. Shall we move forward? Have we got time? I know this is getting very long, sorry, but thank you for sticking with it. Hopefully you're learning. Let's quickly add a keyboard listener, and when any key is held, we'll move forward. Or two keyboard listeners we'll need. We'll do stage.add event listener, keyboard event dot key down, we'll call that key down. Copy it, paste it underneath, change key down to key up, and K down to K up. Right, let's quickly do those functions. Probably shouldn't do them here, but I'm in a rush. Private function K down, responding to a keyboard event. And we need to set a flag here, so let's have a variable up here. Private var moving boolean, and we'll start it as false, just set it straight up there because I'm in a bit of a rush. So when you press a key down, moving equals true. Copy that, paste it underneath, change K down to K up, and when we release a key we want to set moving to false. So now in our update function at the bottom, update, so here we can say if a key is held, move forward. So if, open brackets, moving, I've done this once and I've got to remember what it was. View.camera.position equals view.camera.position view.camera.position dot add, and then we want view.camera.forward vector. So we're going to add the camera's position to its forward vector to get a new position which should move us forward as the camera is looking. Hopefully that makes sense. Let's try it. Cramming a lot into the end of the video, which I don't like to do, but it's good to have the functionality. Hopefully when any key is pressed, we'll move forward, or when any key is held, we'll move forward. So there we are, and if I press my D key, you can see I move forward, and we're moving in the way we're facing as well. It seems a bit choppy. I don't know if that's just because of my screen recording. That shadow looks very odd. Might want to look into getting a better way of doing those, but fairly happy with that for a very first attempt at Away3D. Now I'm going to do my standard tinkering with it for a while and put a much prettier version on the website when I do the video. Hopefully you've learnt from me and we can keep learning together with this one because I'm very new to it. See you next time, bye bye.